Hi, this is Marcelo Vercelli, and thanks for joining us here at Chameleon Labs. We're going to spend some time looking under the hood of a 7603 mic pre. This has become a 2-year R&D project, and we're really excited about finally delivering the unit to the marketplace. It embodies a number of different changes in terms of the technology that we've developed here. That allows us to make this product. It's certainly the best sounding product we've ever made, and we're very, very proud of it. But I wanted to just take some time to take a look at specific features and pieces of hardware that we've developed to make this thing really the best sounding piece of gear that we've ever made. First, we spent a lot of time looking at the metallurgy and the techniques surrounding the whole concept of making audio transformers. And the 7603, like a lot of our other new products, use a transformer input stage and transformer output stage. Today we're going to spend a little bit of time talking about what that means and how it works and what's the impact on the final result. Transformers have been used for decades in high-end studio equipment, and I'd like to tell you just historically why they were used. Number of decades ago, the AC power coming into the building wasn't that clean. We've always were trying to deal with hums and noise associated with the cleanliness of the AC power coming into the building. So the transformer solved a very simple problem, and that was it allowed us to lift the ground. And by lifting the ground, we were able to eliminate hums that really were arising from dirty or unstable AC power. It was never really designed to give you a character or a certain quality to the audio. It was there to make sure that it was completely flat and completely as wide a bandwidth as possible. And here it serves the function of the input stage. So we have a line transformer for line level signals and a microphone transformer for mic level. We're also allowing you to select input impedance, and that means that depending on the gain structure of the microphone that you're plugging in, let's say that you're using a ribbon which has relatively low signal output capability, you may want to lower the impedance of the input stage to achieve slightly higher gain. We spent about 2 years figuring out how to anneal and treat and select the right metals for the laminations that are used in the transformer stage. So we're very, very happy that it's worked out really well for us. We're getting really ideal performance of this new transformer that is enclosed in what's called a mu metal can, a specific type of material that helps you actually isolate the transformer inside from any sort of RF or parasitic noise which may be flying around the air. Remember, these are microphone level signals, which means that they're absolutely tiny. You're talking about minus 40 dB, minus 50 dB, and they're really easy to change to apply some sort of noise which appears in the signal which wasn't part of what your microphone was actually delivering to the unit. Spent a lot of time actually developing a lot of passive components, and this is kind of unusual for any company to get involved, but we were involved in making everything from the switches to designing the potentiometers to designing the heat sinking. I love VU meters, so we designed we wound our own coil for the VU meter, so we actually had some control over the ballistics or the speed with which the needle moves. The inductors, again, inductors are a kind of a sought-after feature set of an EQ, but we really wanted to use them, so we ended up making our own. Even the heat sinks and the output transfer itself is all designed here in Woodinville, and we're very, very happy with it. So let's take a quick look at how the signal flows through this unit. You have the line input transformer and the DI, which are actually on this end of the circuit board. So up here you're going to be selecting line or mic input. The microphone transformer is in the middle. all of the switching relative to selecting the impedance, because you have an impedance selector between 300 ohms and 1200 ohms, is done via relay. We don't, and you may remember looking at some of the classic mic pre's that we've commonly used in the past, that you'll see that the switching was done by flying a wire to the front of the chassis and then back to the back of the chassis. We really can't afford to do that sort of thing in the year 2016. You're now flying very small signals over these wires which act like perfect antennas. We need to be able to protect the integrity of the signal as much as possible, and this board layout and the way it was designed tries to do everything possible to protect the signal. The mic actually now flows into the main switch, and you have some other features up here that you can select. Number one, obviously, once you've selected mic, you can select the impedance, the 300 or 1200 ohms. You can select whether or not you're going to have the EQ in line or not, and it's actually a cool little switch. You'll probably be using this switch the most as you select some EQ for your microphone, and then you compare it to what it's like without the EQ in place. The gain switch and the gain stage was probably a good year worth of R&D. We wanted to design something that was unique, so it is our own design in terms of being a standalone operational amplifier design, completely discrete and Class A. It has up to 70 dB of gain in a single stage, which was probably the biggest challenge for us. You can select a phase, so you can flip the phase here, and we also have the beginning of the EQ. The EQ is actually very, very simple. There's a selectable high pass, there's a selectable low shelf, there's a selectable mid frequency, which is basically a wide Q that we're moving from the mid band all the way up through the 7K. And then there's a high shelf, each one with a level control. Using inductors as the basis for the design of the EQ topology. It's a real sweet sounding, very classical, and almost very British sounding type of EQ. The idea here is that we wanted to, at the electronic level, make this as low noise as possible. Even with the inductors in circuit, we're able to maintain the distortion under 0.01%. Which is quite the triumph. Another thing that, having spent so many years looking at these mic pre's and now being part of Chameleon Labs and working on our first product that includes inductors, we were really, really motivated to understand why they sound the way they sound. And what we found is that inductors have a very particular type of characteristic, in that as the voltage goes up, you have voltage flowing through the inductor. As the voltage is going up, the resistance of the inductor is changing. It's almost behaving a little bit like a compressor would, that depending on the content of the audio, how much energy is in the audio, and it's going to determine how much voltage, you actually have the resistance going up and down. And it has a very particular characteristic. It's hard to make microphones sound bad with this type of EQ. Finally, the thing that we were always very concerned about was the output stage. Typically, how the output stage works is that you have a fixed amount of gain. So let's say that you have an output stage that has 24 dB of gain, 22 dB of gain. That output stage is basically always on. Think of it as an amplifier that is always on. And what you're doing with a pot is releasing signal to drive that output stage. So if the signal's all the way off, your pot's all the way off, you still have the noise floor from that amplifier being always on. And so one of the things that we wanted to do was develop an output stage that had huge gain capability, robust gain capability, but also had a variable gain stage. So that means that we actually don't have the output stage on, we actually have the output stage off, and basically they work together. So when you turn down the level, this unit has much, much lower noise floor than your standard average microphone pre. And that was very important to us. It's also very important to us to have very good gain capability because of the way we want to drive the output transformer. The output transformer is basically your color palette for your microphone pre. The relationship within the laminations of the output transformer and the gapping of the core is extremely important in terms of getting a particular type of sound. That gapping actually creates harmonics, and those harmonics can be very, very pleasant. And it makes things sound, to use, for lack of a better word, sounds very sweet. We spent a lot of time figuring out the laminations and choosing it, figuring out the gapping, and then most importantly, figuring out exactly how much DC voltage, DC current running through those laminations was required to get this sweetness and to get the consistency, which allows us to be able to manufacture it consistently. So this is where the 7603 has its own character, its own color. And that's also very exciting. And lastly, we talk a little bit about the functionality, some of the things that we've added to make it easier to use. First thing is that you have overload lights, and the overload lights will come on when you hit plus 4 dBu on the output. The next thing is the functionality of the VU meter. The VU meter allows you to actually be able to monitor the input, monitor the output, and then you have a 0 dB or a minus 20 dB pad so that you can actually see the level of the VU meter running with a 20 dB pad on top of it. Lastly, there's a number of ways to use this unit and to get different results. You can actually let's say, turn the input sensitivity down on a microphone and use the output to overdrive the transformer. And as you overdrive that transformer, you're going to get a higher level of harmonics. You'll be able to get a certain feel and texture to that particular setting. You can turn the input level all the way up and then now barely drive the output transformer and to get the same amount of total gain, but you're going to get another color. So that's the fun part about being able to use a unit like this. And then of course add the EQ with the high pass filters in place, and then it's kind of, you can use the high pass filter, say at 80 hertz, and then you can actually add more lower shelving. So you're adding a little bit more of energy, but the energy is actually flowing through that inductor. So that's another way of adding and changing the character of what it is that you're actually going to be recording. I think finally, all of our units, we've developed a really sophisticated switch mode power supply. This allows you to use the unit anywhere in the world, from 100 volts to 250 volts AC in the wall. No problem. You can carry it and use it anywhere you'd like. Thanks very much for spending some time with us. Look forward to our next little sit down, and take care.